Hi, this is chapter 4, lesson 2, our first lesson. So yesterday we graphed a two-part graph, and there was a curved L shape in quadrant 1. There was a curved L shape in quadrant 3. And so today we're going to do the exact same type of graph. The graphs that we're going to see today are going to look exactly the same, but I have to do one step more to set it up. It's not just given to you easy like it was yesterday. And so these are called rational functions. And we started out just now by looking at my f of x and my g of x and my h of x. So class, can you tell me some things that you just talked about? Like, what's the same? Because here's the deal. I have part E. I know it's at the end, but it's fine. What's the same and what's the difference between f of x and g of x? So, one statement. The what? They both have x minus 1. Awesome. Tell me more. Yep.
The difference is like a denominator because f of x technically has a denominator of 1 and g of x technically has
Yeah, g of x has a denominator of 2, so I like divided by 2 on g of x. Okay. So the denominator is different. Oh, different. Sorry. I'm just gonna put denom. Did anyone know like the shape of the graph? Like f of x, is that, what's the shape of this graph? A line, linear. With my slope of 1 and my y-intercept of -1. What's the g of x shape? Is it curved? Is it straight? Is it what? Well, okay, let's rewrite it. X over 2. That would be 1/2 x. And then -1 divided by 2. -1 divided by 2. What's this right here? What kind of graph would this be? Linear, something you would have learned in Algebra 1. This is also linear. However, my slope is 1/2 instead of 1 because I cut it in half. Remember, I divided by 2. My y-intercept is -1/2. Yeah. F of x cut in half completely. So, what is the effect on the graph of f when I divided x minus 1 by 2? So, g of x I divided by 2. Each y value is half the previous value. Okay, I really need to start talking about h of x now. In h of x, what kind of graph would this be? Is it linear? Yesterday we graphed and there was an x in the denominator. Today there's an x in the denominator. Would that be a straight line? No. We can use our process of deduction, right? Not linear. The only thing I know about this is that a y-intercept would be 1/2. And I know that because of the ends of the binomials, the numerator and the denominator. Okay, so let's see. What is the value of h of x when x equals 2? H of x here when x equals 2. So I'm going to plug it in. 2 minus 1 over 2 minus 2. One over 0. Oh, what's that? Undefined. Hey, that might be where my asymptotes are. Oh my gosh. Right? Yeah. Okay. So, part D. What is the effect of f of x? Here's f of x. When I divide the x minus 1 by x minus 2. They're saying f of x to h of x. These two that I'm pointing at. H of x is not linear. H of x, by the way, is going to look like this. Approximately. I'm not being perfect. Approximately. Part F. What happens? What do you notice about graphs that have a variable in the denominator? What happens when I put an x in the denominator? Curves, nonlinear, different.
Get asymptotes.
They get asymptotes, and they're nonlinear. We call that a rational function. The parent function being y equals 1 over x. So, what's going to happen? Step 1, step 2, and step 3. We're going to graph asymptotes, and then we're going to choose x values on either side. So we're just on step 1 and step 2 and step 3. That's this. Up here on the board. If I know that my asymptotes are these orange lines, if I know that my asymptotes are these orange lines, okay, then I need to choose values that are over to the left because I want to know what's going on this side of my asymptote. Is the graph up here? Is it down here? So I'm going to pick something lower, less than my asymptote. I'm also going to pick something bigger than my asymptote because I want to know where the graph appears to the right side. So I'm picking values over here, like maybe I pick like this number, and then I can draw a line through it. Remember, we're not doing exact. This is all approximate today. I'm not even going to use Desmos. Or maybe I get a point that's right here. It's like, oh, okay. Maybe it looks like that. So if I have a few points, 2 to 3 to 4 points, I already know what the shape is going to look like. So let's turn the page and actually do it. Now remember, this is going to be exactly the same as we did yesterday. Yesterday was 4.1b. Here we go. Example 1. Rewrite the rational function g of x equals 4x divided by x minus 3 using long division. Okay, here's long division. The denominator goes on the outside of the fraction. The numerator goes on the inside. And I am. Okay. So it's a binomial. How many times does x go into 4x? 4 times. So I put a 4 above it. Then division, this is like 4th and 5th grade division, I multiply. 4 times x, 4x. 4 times negative 3, negative 12. I don't have anything to bring down. What do I do next? What? Subtract. So, 4x minus 4x. Nothing. Nothing minus negative 12. Be careful. Minus negative 12. 12, that's going to be my remainder. It goes in 4 whole times with 12 as my remainder. So this is how I would write it. It goes in 4 whole times, and I have 12 as my remainder over what did I originally divide by. So this looks good. This is what we did last chapter with long division. However, this does not help me with yesterday. Yesterday, I wrote the fraction first. So I'm just doing commutative property, and I'm going to reorder it. When I reorder it like this is something I'm really used to. I saw this yesterday. You know, my H is 3 to the right. My K is 4 up. This 12 means that the A, it's like a big old stretch of 12. It pulls my curve L-shaped away from the center. That's what a stretch does. It pulls it away. It's not really close in the middle. So, describe. Okay, ready? A stretch of 12, 3 to the right, 4 up. My H is always my vertical asymptote. My K is always my horizontal asymptote. What's the formula for my vertical asymptote? The dotted line formula is what? It's vertical, so is that x equals or y equals? X equals, what's the number for H? 3. See it up there? What's my vertical asymptote? 4. And what's the formula for that? Y equals 4. So, I drew in red my asymptotes. Now, great. I know my boundary lines. Because this is a positive 12, I know that it's going to be in quadrant 1 and quadrant 3. Like that. Yeah. So, back to what was in like start at the top of the paper. Don't make a table of values. Pick values on either side of my red line. So I need to pick something like 3 or 2 or 1. And I can also pick like 4, 5, or 6 over here to the right. So, in this blank space up here, I'm going to pick some things. I'm going to pick x. What if x is 0? What if x is 5? What if x equals 8? Okay. So, plug it in. That wasn't very fun, this whole, let's see, 4 times 0. I thought 8 would be a good choice. It's kind of like, So plug in 0. 4 times 0, 0 minus 3. That's 0. Plug in 5. Okay. My numerator is 4 times 5. My denominator is 5 minus 3. 20 over 2. That's 10. So this is now my y value. When x is 5, y is 10. Eight. 4 times 8 is my numerator. 8 minus 3 is my denominator. Okay. With these 3 values, yes, sir.
How'd you get the 4x over x minus 3? Where you're like plugging in the.
This was my original equation up here that I started with.
Oh, okay, that's great.
Yeah, so you want to start like plugging in the original. And I randomly pick these numbers. Something on the left, 0 is so easy to plug into anything. And then 5 and 8 was just me kind of trying to figure out whole numbers. So 0, 0. I'll make them really obvious. You guys, this is the only point I have. I'm just going to randomly go like, it's approximately that. And I'm not going to be sad. It's not perfect. That's fine. Over 5 up 10. Over 8 up 6. Look at what the 12 did. Where did I say 12? Where did I get 12 from? I got 12 from here. This is like what we graphed yesterday. If I have this 12, look at how far it pulls it from my asymptote intersection. That's what the A stretching does. 12 is a big number. So it really pulled it far away. All right, I'm ready to move on to the example 2. Sorry. Okay. Use long division to rewrite it. Great. First things first. X minus 1, 6x. X goes into 6x. How many times? Okay, now I multiply. 6 times x, 6x. 6 times negative 1, negative 6. Subtract. Go ahead. This means it goes in how many whole times and what's the remainder? 6 and what? Someone say it louder. I hear you talking, but 6. Rewrite it or put the fraction first. H is negative 1, K is 6. That translates to down here. H is my vertical asymptote, K is my horizontal. All right. Describe the transformations. I have a stretch of what? And write what? And new people, please. Great. Stretch of 6. Thank you, Heman. I'm sorry, Hanim. Sorry. Right what? Left what? What is it? Left 1. Right 1. Because remember how it's the opposite sign? It's the same as before. And 6 what? Up 6. Please make your dashed lines and your vertical asymptote. Okay. I'm not going to make a table of values. What am I going to do? New people helping. All brand new. What do I do? Pick numbers on each side. So you have to pick a number that's smaller than 1. You should probably pick 0. Pick a number bigger than 1. So I could do x equals 0 for sure. 2. Give me another one bigger than 1. 8. I heard someone say 8. Why not? Anything you want. Plug it into the original function up on top. So 6 times 0 over 0 minus 1. Then plug in 2, and then plug in 8. Now I'm plugging in 8. Wow. Okay. Plot those points and draw approximate lines through them. It doesn't have to be perfect. 2, 12 is actually off the graph, but that's fine. And then I'm going to graph over 8, up 6 6/7. Good.